Profile leveling. Do you know how engineers come to decide as to how much earth is to be cut or filled to make a leveled construction? Have you ever wondered how to determine the depth of cutting or filling on the proposed gradient? Well, it is determined by plotting a profile leveling. And now we will learn in detail how it is done. Profile leveling is a method of surveying that has been carried out along the central line of a tract of land on which a linear engineering work is to be constructed. Profile leveling is also known as longitudinal sectioning. The line along which a profile runs is to be marked on the ground before taking any observation. To carry out profile leveling, firstly set up the level on a convenient location, say L1. Level the instrument and take a backside on A, marked as the benchmark. Now, mark points at regular intervals, say 10 meters, on the line up to the turning point TP1. Take the observations at these regular intervals using leveling staff. Take a foresight on turning point TP1 and note down all the readings. Now let us reposition the instrument to some other convenient location L2. Set up the instrument and level it on the location L2. Now take a backside on TP1 and take readings at regular intervals using a leveling staff. Now take a foresight on the final station C and also take the readings at salient point, say X, where changes in slope occur. As soon as readings are taken, the notes of the profile are recorded in a level notebook. The readings are filled in the notebook as follows. For instrument position at L1, the backside is taken at benchmark and the reading of 3.005 meters is placed in its column in the row of station A. The readings for intermediate sides for 1 is 2.285 meters, 2 is 1.56 meters, 3 is 1.785 meters, and for 4 is 2.105 meters are placed in the corresponding row. The foresight taken at the station TP1, 3.105 meters, is placed in its row. After changing the instrument location, the backside at TP1 is entered in its row in the backside column. The readings intermediate sides for 5 is 3.465 meters, 6 is 3.12 meters, 7 is 3.015 meters, 8 is 2.58 meters, and 9 is 1.955 meters are placed in the corresponding row. The readings of the salient point X is 3.955 meters is placed between the intermediate sides at its place. The foresight 1.465 meters taken at station C is placed in its row. The reduction of levels can be done either by height of instrument method or rise and fall method. The following table indicates the computations done by both height of the instrument and rise and fall methods. Now that the reduced levels of various stations are known, let us learn how to plot a profile. Plotting of profile leveling provides a graphical representation of the ground points on a longitudinal section along the alignment. The vertical scale of the profile is generally drawn much larger than the horizontal scale in order to accentuate the difference of elevations. To plot a profile, a datum line is drawn along which distance of points are marked. The reduced levels are plotted along vertical lines drawn on marked points. Segmented straight lines joining the reduced level points represent the longitudinal profile of the ground surface. The following figure shows the complete profile of longitudinal section of the profile leveling.